Hi there. In this video, I'm going to walk through 3 heparin dosage calculations using the formula method, a must-know skill for nursing students. We'll cover how to calculate a heparin IV bolus, a weight-based heparin drip, and how to adjust the dose based on an aPTT lab result. These are common problems you'll see in clinical practice, exams, and the NCLEX, so let's build your confidence by solving them step by step. Here's the first scenario, administering a heparin bolus. The medication ordered is heparin 80 units per kilogram, IV bolus once. The medication supplied is 1,000 units per milliliter. The patient's weight is 70 kilograms. We'll use the formula to determine the correct dosage. Apply the formula. Start by placing the quantity of the medication supplied. In this case, the medication is in a 1 milliliter solution. Place 1 ml in the formula where the quantity goes. Then, identify what dose you have. The dose is 1,000 units. Place that number in the formula where it says have. Then, you need to identify the dose you want to administer, which is what was ordered. In this example, the dosage is 80 units per kilogram. You will need to determine the dose based on the patient's weight. 80 times 70 kilograms equals 5,600 units. Place that value in the top part of the formula. Now you can calculate the amount to administer. 5,600 divided by 1,000 equals 5.6. Multiply that times 1, and the answer is 5.6 milliliters. Administer 5.6 milliliters to deliver 80 units per kilogram IV bolus. Always review your answer to make sure it makes sense. The reverse method is to multiply 5.6 milliliters, the amount to be administered, by 1,000 units, the concentration available, which equals 5,600 units, the prescribed dosage. Let's move on to the second problem, a weight-based heparin drip. The amount of medication in the drip is based on the patient's weight, and you need to calculate the rate to set the IV pump. Remember that the IV pump is always programmed in milliliters per hour. The medication order is heparin 18 units per kilogram per hour. The medication supplied is 25,000 units in 500 mLs of D5W. The patient's weight is 70 kilograms. What rate should you set the IV pump? Fill in the formula components. The quantity of the supplied medication is 500 milliliters. Place that in the formula. The desired or prescribed amount is 18 units per kilogram. Calculate the dose by multiplying the 18 units by the patient's weight of 70 kilograms. The desired is 1,260 units per hour. Place that in the formula. The dose you have available is 25,000 units. Place that in the formula. Solve for the amount of milliliters to be delivered per hour by solving the equation. 1,260 divided by 25,000 is 0.054. Multiply that by 500. The heparin supplied should be administered at 25.2 milliliters on the IV pump. Always review your answer to make sure it makes sense. The reverse method is to multiply 25.2 milliliters, the amount to be administered, by 50 units, the concentration available. 25,000 divided by 500 equals 50 units per milliliter, which equals 1,260 units, the prescribed dosage. Let's complete one more calculation, where the heparin dose is titrated to a lab value, the aPTT lab value. The initial order is heparin 18 units per kilogram per hour. The medication supplied is 25,000 units in 250 milliliters of D5W. The patient's weight is 80 kilograms. The target aPTT is 60 to 85 seconds. The patient's aPTT result was 48 seconds. The protocol reads that if the aPTT is between 45 to 95 seconds, you increase the drip by 2 units per kilogram per hour. Let's calculate the initial rate first. The quantity of the medication is 250 milliliters. Place that in the formula. The desired or prescribed amount is 18 units per kilogram. So multiply 18 times 80 kilograms to get a desired dose of 1,440. Place that in the formula. The dose available is 25,000 units. Place that in the formula. Solve for the amount of milliliters to be administered per hour. 1,440 divided by 25,000 is 0.0576. Multiply that by 250. You would set the IV pump at 14.4 milliliters per hour. Always review your answer to make sure it makes sense. The reverse method is to multiply 14.4 milliliters, the amount to be administered, by 100 units, the concentration available, 25,000 divided by 250 equals 100 units per milliliter, which equals 1,440 units, the prescribed dosage. Now, let's calculate the IV pump rate for when the aPTT lab value is 48 seconds. The protocol reads, if the aPTT is between 45 to 95 seconds, increase the rate by 2 units per kilogram per hour. The aPTT is 48 seconds, which means the rate must be increased by 2 units per kilogram per hour. So you would calculate the rate the same way, except the patient would be receiving the dose of 20 units per kilogram per hour. The quantity of the medication is 250 milliliters. Place that in the formula. The desired or prescribed amount now is 20 units per kilogram, so multiply 20 by 80 kilograms to get a desired dose of 1,600 units. Place that in the formula. The dose available is 25,000 units. Place that in the formula. Solve for the amount of milliliters to be administered per hour. 1,600 divided by 25,000 is 0.064. Multiply that by 250 milliliters. You would set the IV pump at 16 milliliters per hour. Always review your answer to make sure it makes sense. The reverse method is to multiply 16 milliliters, the amount to be administered, by 100 units, the concentration available. 25,000 divided by 250 equals 100 units per milliliter, which equals 1,600 units, the prescribed dosage. Practice makes precision. Keep on practicing to build your confidence. In the next video, you will find practice problems for complex medication doses, utilizing the formula technique. The more you practice, the more confident you will become. Thanks for watching. If this video was helpful, give it a like. Share it with your classmates or coworkers, and subscribe for more nursing education content. You can find more videos at nursevideohub.com. Watch, learn, and care.